Kia ora, year 12 and 13. Here's another really old excellence question, this one from 2007. So this question's a bit different. It's quite fiddly to get the correct answers and not miss any situations out, but it's pretty clear what we have to do. We have to figure out the values of t when this parametric function is concave up. So let's first of all think about what does it mean for something to be concave up. Well, concave up, as someone in this year's A-level class said, is easy to remember because it means second derivative is up, so it's positive. More meaningfully with a graph, concave up is a situation like this one where the gradient is increasing. So if you have trouble remembering it, just take your pen in the exam and draw a parabola and draw the gradient. So here it's really negative, here it's less negative, here it's 0, but all the way through here the gradient's increasing. They're meant to be straight lines. Okay, so what we have to do is we have to find the second derivative and figure out where is it positive. So we're quite used to doing the first derivative with parametric, but we have to be a wee bit careful with the second derivative. So the first derivative, when I've got an equation defined with a parameter t, comes from the chain rule. Right, so what we have to do is differentiate this with respect to t and differentiate this with respect to t. So that's step one of this question. Actually, I'm going to pause the video to do this bit because this is super easy. Okay, so there are my first derivatives done. So putting those together, we get dy by dx, which is 6t minus 7 times 1 over 12 squared, or many of you will have done this so many times you'll be used to thinking of it as y dot over x dot. And by the time you get to the exam, that's how you should be thinking about it. Right, so we take dy by dt and we divide it by dx by dt. So that's all good. That's the first derivative, but we have to get the second derivative. So just cleaning up the first derivative, we get this. Right, so the second derivative is what we get when we take dy by dx and we differentiate it with respect to x. Only trouble is that this is done with respect to t, so we have to use the chain rule again. So this is really just a little bit of quick revision of the second derivative when you're doing parametric. So we now need to take this and differentiate it with respect to t, and then times by dt by dx. Now, if you look at this and you don't think about it first, I'm sure some of you are going to go and do the quotient rule on that. You can try that, but you're going to make a mess. You will get there, but it's much easier to split dy by dx up into two bits. So we've got 6t over 12t squared minus 7 over 12t squared. And I can rewrite that as 1/2 t to the negative 1 minus 7/12 t to the negative 2. And suddenly that looks very easy to differentiate. So the derivative of this with respect to t is going to be -1/2 t to the negative 2 plus 14 over 12 t to the negative 3. Right, now let's just clean that up a little bit. We get we get that, plus, what's this, 7 over 6t cubed. The second derivative with respect to x is this. Right, so times dt by dx, which was 1 over 12t squared. Remember, our goal is to figure out when is this thing positive. So we get -1. So this is what I mean. The question's really easy to see what to do. It's just a little bit boring. Not that maths is ever boring, but it just about is right now. There we go. We've got that for our second derivative. And we want to have that positive. Right, so let's get a common denominator and then start checking different situations. So we don't like the fact that we've got t to the power of 5 here, but we have. So I'm going to multiply through by 3t plus 7. Okay, so just be really careful here. We've got two cases. What happens when t is negative? We want to have this thing be positive. When t is negative, 72t to the power of 5 will also be negative. But negative 3t will be greater than 0. So negative 3t plus 7 will be greater than 0. So the whole thing will be a positive over a negative, which will be negative. So there are no values of t for that side. So that's quite good. Now, what about when t is positive? So 72t to the power of 5 will be positive, and we need to figure out when so that's what we're doing. Right, so this is a very simple little equation. We've got 7 minus 3t is positive, 7 is greater than 3t, adding to both sides. 7 over 3 is greater than t, so t is less than 2 1/3. But that is not my whole answer. If I just wrote that, it wouldn't be too good, because we're just looking at times when t is positive. So we're going to say this: the relationship is concave up when t is between 0 and 2 1/3. Okay, if you need some practice at going over the second derivative in parametric, and you're in my class or at WC, just send me an email and I'll send you some practice questions back. I think it's done in Education Perfect, and I think there are also some examples in the Delta textbook. Thanks for watching. Sorry, this is a little bit too long.